Ikaaġvik Sikukun, new pack for ice bridges.
In March of 2018, I flew to Portland, Oregon to meet up with team members Scott Brown and Nathan Lochzog and drove Highway 26 east through the snowy pass to Warm Springs, Oregon. The intent for the trip was to cold climate test our newly engineered drones before using them for official data collection in the cold climate of Kotzebue, Alaska.
Launching. Launch now.
We're here in Warm Springs, Oregon, about a 1-minute drive away from the flight area. That's about a 5-minute drive away from Kanita Lodge, just over that way. Hope to do several flights with each payload, test all of our sensors, test the UAVs themselves. Yesterday, there was some basic communication testing between the ground station and the UAVs themselves. And Scott, the payload engineer, was working on assembling and testing all of the different individual sensor payloads and how each of those operate outside of the drone. And those will be put into the UAVs today and flown about. This afternoon we had a successful, very stable hover test, and we'll be doing some more extensive tests with the payloads today and the rest of the week.
University of Alaska at Fairbanks is the test site lead, and we started the Pan-Pacific Test Range back in 2014, and we're one of 6 test sites across the U.S. that was approved by the FAA for unmanned aircraft testing. We can establish their flight authorizations through public aircraft COAs and through the FAA, which allows them to fly unmanned aircraft in the national airspace. So we began working with Latitude and Columbia University as a team last year.
Wow, it's bigger stuff. Yeah, this is general fabrication area. So you see, like over here, we got the last fuselage for the HG60 project going on.
They're looking for cold weather testing and vetting of their payloads as well, and some of the flights will be done in Alaska and Kotzebue. But for the initial testing right now, while the weather is extreme in Alaska, this provided a perfect environment where it was cold enough, but we get 300 days of sun and an expansive area to fly in. So that's why they chose Warm Springs for the first phase of the testing. The initial reason for coming to Warm Springs was to cold weather test the batteries, make sure that they're functional in cold weather before we take them down below 32 degrees Fahrenheit or 0 degrees Celsius. So this provided a step process so that they're not going to extreme cold initially, and also vetting several of their payloads.
Due to the fact that we have quite a change in the climates and geographical locations, we gave them a choice of where they could go based on what they really need to do for flight test. So we have the climatic changes of Hawaii. We have the Arctic climate of Alaska. We have moderate climates in the state of Oregon as well, to where we are here at Warm Springs, which is a moderate climate, and we're here doing some cold flight tests.
So we've been out here since Monday, and we've done 6 flights so far. 2 of them were just static hover tests, making sure the system worked properly before we transitioned to forward flight. We had 2 functional check flights on the airframes that is also just for us to make sure everything is still working properly. And then we've had 2 different payloads on 2 different flights that have flown for about an hour so far. And then today we're looking to do 1 more long flight with the 3rd payload and see what we get for aircraft performance and engine fuel burns from the new propulsion system we're using and data from the payload.
And it looks like we got good data right off the bat.
Some of the things I was involved with on this airframe specifically was integrating the forward propulsion system. Launching. Launch now. Spin up. Lift off. After the plane lifts off and transitions to forward flight, as soon as it comes off the ground, I'm looking for any abnormal behavior in hover, any erratic behavior between the point it's on the ground to the point it starts transitioning to forward flight. In this situation, since we're required to have a visual observer, one of us has to be out here obviously keeping an eye on the plane, and then the other is flying the plane, the PIC. The person, pilot in command, will be internal, actually sending any commands to the aircraft. I'm in touchdown. 60 feet. Looking good. 20 feet. 10 feet. Stand by for VTOL kill.
This is basically the base acquisition GPS and DVR for recording camera data. There's one of the cameras here, and also 4 instruments that measure solar radiation, 2 look up and 2 look down. It just tells you what's incoming and what's coming back up, and you can tell how much is being absorbed. Infrared on the left and visible on the right. This is the hyperspectral imager. It's going to measure and quantify various colors that we're looking at. So if we're looking at colors of the ice, it'll tell us when we fly over different kinds of ice, how the color changes, and then it's our job to try to explain why.
Out here in Warm Springs, we've been doing functional tests on the battery warmers, making sure they're warming properly, checking cylinder head temperatures on our pusher motor to make sure that it's not running too cold. We're really just going to be cycling through the payloads and testing them against the aircraft, making sure there's no radio interference between the airplane and the payload, and seeing if everything's working properly. We designed these planes in the desert where it's dry and warm all the time. So this is all new territory for us. Kotzebue is going to be the opposite extreme. It's going to be cold and wet, and there are conditions we're just not used to. So we're really trying to cater to that. I think that we're going to learn a lot when we get there, for sure, and we're doing our best to test everything beforehand, but when we get there is going to be really when things kind of come together.
It seemed that many things were learned about the drones, the payloads, and how things operate at various temperatures and humidity levels. It was nice to have an opportunity to drive the drones across lower US states with easier access to technical resources to make changes to the functionality of the drones or payloads if test flights proved necessary. After this trip, the drones will need to be packed up and hauled on a plane up to the remote village of Kotzebue, Alaska, where there are no roads leading in or out.
Ikaaġvik Sikukun, and you pack for ice bridges.